Hello and welcome back to the lab. Today on the bench we have something very much on the older side of things, but still very cool and very relevant. And will probably be some foreshadowing as to a direction the lab's going to be going. So, I was not going to turn the camera on for this, so I will admit this one I have been in. I've already been doing a little bit of restoration work on this one. However, I was talking to some other technicians that I know, and they kind of smacked me in the back of the head and said, "What are you doing? Turn the camera on and do a video." So, this is that video. There's a reason why this hit the bench, and I'm not going to get into that too much in this video, but I do want to do a check-in on this. We're going to fire up a couple of the voltmeters and do the best we can getting this checked into the lab. Now there's going to be some challenges there, and I'm going to handle that the best I can, but it's not going to be ideal. So with that, what's in the case? Today for restoration, we have a very bad camera angle. Let me reposition the camera. We have a Stark 966A mutual conductance tube tester. I have needed one of these in the lab for a little bit now. I've done a little bit of tube work that's been off camera, and I do service some amplifiers and things like that, but I haven't really had a tube tester, and I needed to fix that badly. Opportunity came up to pick up this unit. I didn't even see pictures of it. I bought it sight unseen, and this is what came in. Case is in a little bit of rough shape. However, the tester itself is in very good condition. I don't mind the case. It's actually a wooden case. I don't know if the camera's picking that up, but it's been a while since I've seen anything in a real wood case. The veneer's torn in a couple of places, but it does latch. I picked it up and there was a thump. Someone else has been in here before me, as the screws are gone and missing. They're not even here. So this whole panel is already moving around. Lots of reading went into this video. This one, since I haven't done much with tubes, I did read the manual for this Stark, so I knew exactly what it was testing, how it was testing. That's very important with working with test gear, is to knowing what signals they're putting out and what they are testing and what the measurements are telling you. Also, it was a good thing I did, because this shorts control, you must check the tubes for shorts before you hit the test button, because if you don't, you can damage the tube tester. So that was a good thing to know. So definitely take a look at some of the manuals. The other thing is, from doing some digging on the internet, if the bias control or the English control in this one is dead, the tester shot. This is a custom potentiometer under here. It's a double stack custom taper. This is also a custom tapered potentiometer too. So if either of these two controls are dead, forget it. You will need a replacement from another tester. I've done a few things for the trying to get some analog meters on the bench. I have not had some very good luck yet getting those out. That was very early when I started recording videos for YouTube. I have some meters where the movement was damaged, and that was it. The meter was just dead. But I have checked the movement on this one. The movement is good there, so we are good to go. So where are we at with this particular unit, since I have been in this a little bit, and this is like a normal video where we are starting at the beginning. I have checked it. Everything does seem to function. And I have replaced 2 capacitors in this unit already. The manual said that they were a paper. This is one of them. The other one was a generic capacitor that was on the back side of the meter to protect the meter from voltage spikes. So got that replaced, and I got this cap, this old paper cap, replaced. This did test good. Like, I checked it for leakage, checked it on the SMU, checked it on the Heath kit. Everything was fine with it. It was checking okay, but given that it's a paper in oil, it's gone. We did take into account which direction the capacitors go. For those that don't know, the band side needs to go to the lower impedance portion of the circuit. So the new capacitor was checked for direction and was put in the correct way. I want to address this line cord. This is old enough where it does not have a polarized line cord. So that is one thing we are going to change. I have a nice cloth wrap line cord that's in here. And we're going to do a little bit of testing when the meter warms up, but I also would like everyone's... This has not been plugged in a while. Get a towel to protect this meter face here real quick. Since it's not scratched, let's not put a scratch in it. So, these tube testers are based on the Hickok design. It's supposed to have a type 83, and this is, I believe, a 5Y3. Yes, 5Y3. For rectifiers. So, you will notice there is no 83 here. I'm going to do some testing on this. This is a solid state 83 replacement. Loosen this up a bit. And you can see there's a couple of diodes, and there are some dropping resistors in here. I'm going to check the meter. This is going to very much... This could potentially skew the readings on the meter. And finding a bogey tube, at least at this day and age, is not going to be easy at all, especially given the tolerances of these particular units. One of the reasons I was interested in getting a tube tester is this guy right here. The filament switch on these has lots of different filament voltages, and that's very hard to duplicate outside of a box like this. So I have some other plans on kind of maybe interfacing some more modern test gear with the tube tester in the future. We will see how that goes. I also have some more to try to create and better measure a tube to validate this tube tester. I am debating on doing some form of validation with my current or future source measure unit to get some very accurate readings of some tubes. My current SMU only goes up to, it's either 100 or 200 volts. I think it's 200 volts. So it would not be very good for testing. It would be good for testing some tubes, not others. I'm really looking at getting the 2470. I also want a 2461 as well, but the 2470, depending on how things go, might be here first. That one will put me at 1100 volts on the SMU. So, future plans. The capacitors that I replaced are located here. This is a 100 microfarad. 100 nanofarad capacitor there, and then the meter capacitor is tucked right here, just across the back of the meter. This is a 400 working volts DC capacitor. This one will be fine. However, this is quite overkill. This capacitor is a 2000 volts rated for isolation, so it is much. It's very overkill for this particular location. Other than that, everything seemed to be okay. I'll buzz these resistors out real quick once the meter warms up, and we'll just sanity check them. The other capacitors in the circuit were mica, so nothing needed work there. The roll's in really good shape, although I did print out, I did find it online. I created a binder with the additional data books and everything for the Stark tube testers. The 966, the 966A, and the 966U, I believe, are all very similar testers. They all have the same circuit. They all have the same design. The main difference is they add sockets, and the difference between the 966A and the 966U is one does TV tubes, this one does not. So I'm okay with that. I don't really see working on tube TV sets much, at least for now, in the lab's future, so was not too torn up about that. This is that dual gang pot that is problematic if it is broken. Here's our line cord, which we're going to replace. So it looks like switch and into the line adjust potentiometer, which has actually got plenty of play on it, to be honest. I'm not near the end stops on that one. So let me get all these switch contacts serviced and everything all working and serviced up. I got to service this bank of switch contacts, and then I will bring everybody back when it's time to swap out this line cord. Man, that was an argument. This cord must have expanded over the years, because that was... it's still in good shape. It's just not polarized. So I'm going to... Actually, I may save this one. There might be a use for that later. Still nice and supple. It's not hard and cracked and brittle yet. But getting it out of this hole down here, it was hard. Now this grommet, on the other hand, this is in really bad shape. It's tearing in half. So we are going to get a... definitely going to replace this grommet with a new one, because this has deteriorated. And just that was enough to... Just this grommet, actually. This grommet right here. This grommet has deteriorated, and I do want to replace this. That's enough for taking the line cord out and replacing the line cord with a new one, is to refresh this grommet. So let me grab a grommet out of my storage. I've gotten all the switches and everything cleaned. That while I was going through that, I noticed something very specific, and it is right here. So we are looking straight down towards the bottom of the unit. The meter's here. This is the one of the towers. There's some inductors and resistors here. It's actually pretty tall. It's off the board about yay far. Doesn't look it, but there's supposed to be 2 adjustment resistors here, at least in the calibration document there is. They've been removed for this unit. Now, this looks factory. This looks like a factory resistor. Everything, I don't see like wires hanging out saying that they've been stripped and they're missing. But there's no way to, there's no calibration adjustments on this at all. So it's kind of going to work or it doesn't. Appropriate rubber bits later. Oh yeah, that's nice size. All right, we'll just get this new. Actually, let me make sure the cord's gonna, the new power cord's gonna fit through. New grommet installed. Okay. Now let's thread this line through without screwing up this nylon wrap, because this is a nice cloth wrap cord. Figured it'd be nice for this vintage piece of equipment to give it a nice vintage cord. Now, the tricky part's going to be making sure the cloth actually goes through the grommet, which it doesn't want to, of course. Now, this is not a vintage cord. This is a modern reproduction cloth wrap cord, so all of the modern safety items are in place. It's not good. I'm going to have to employ the fire again. All right, there we go. Okay, the knot's through. Got the cloth through without damaging anything. That's the important part. So now... Oh, don't fall in. bottom side goes this way. Make sure this is done the right way. You don't want to have to rethread this again, but now we're coming out of this hole right here. Okay, I've got the box put back together. I have the new line cord put in, along with the strain relief on the inside of the case and on the outside of the case. I'm going to put one more strain relief in here if everything works correctly. I am hooked up to the current limited Variac supply. Actually, I'm going to tweak down the Variac. That's running the voltage a little hot. And let's go ahead and turn on the unit. Pilot light came on, so that's good. We have a little bit of a glow on the dim bulb tester. I'm going to give it another half amp. And that killed it completely, and we're up to line voltage. So it's drawing about 21 watts. Let's check line adjust. Oh, hey, look, there we go. All right, that looks good for what we did. Everything looks healthy there, so let's give it full. We will bypass isolation transformer because this is an isolated unit. I'll just kick it over to the mains, and we'll give it full beans and see what happens. Okay, we are now up to full line voltage, and we are drawing 27 watts. Let me move you guys so you can see what I'm looking at. Gonna dim some lights down so the reflection isn't horrible. 27 watts, we're drawing about 225 milliamps and at 124 volts. So the lab is running quite hot for line voltage today. Okay, so next up, let's check some voltages because I'm not sure about that solid state 83. Okay, to help with doing an alignment, I got one of these, which is kind of cool. It's got, it's actually a socket extension, but it brings the voltages up to the top of the tube, so I can have a tube in here while I'm testing the pin voltages on the unit. So, I'm going to clean these pins, because these are very disgusting. Focus, come on. And we're going to get these cleaned up, these top side cleaned up so I get a good connection. And then we will check some voltages. Okay, so pushing P7 line voltage adjust control from minimum to maximum. Meter should read 1,000 to 1,800. P7. Yeah, we're over 2,000. Ooh, but we are running hot. But I can't adjust it. But our line voltage is also hot. So let's put it on the Variac and give it 117 volts and see what happens. Okay, we're at 118-ish. Let's come down to 117. Check this again. Yeah, still a little high, but better. Okay, so it is a voltage problem on the line. Okay, so meter needs to be in AC volts. Filament switch H and R. H and R. And we want to check filament voltage readings. So bring this down to 0.6. Line test, we are good. And the meter should be in 2 and 8. So we go into 2 and we go into 8. Okay, 0.6, that's okay. 1.1, that's good. I'm checking this at full line voltage. I've got 1.16. 1.5 is 1.48. 2 is... Wait a minute. Ah, there we go. 2 is 2.1, 1.5 is 1.50, 2.5 is 2.83, 3 is 3.49, 4.3 is 4.6, 5 is 5.6, 6.3 is 6.7, 5.7 or 7.5 is 7.9. 10 volts is okay. 12.6 is all right. Everything's reading about is a touch high, but not bad. 20 is 21. 25 is 28. 35 is 39. 50 is 55. 75 is 81. And 117 is 126, which is the line voltage. So, yeah, it's just because line voltage is a touch high. If I move this over to the 117 volt line, I'll show you what I mean. So here's the meter with it on the 116 volt line. 75 volt filaments, 50, 35, 25, 20, 12, 10, 7.5, 6.3, 5. Slow this down a bit. 5, 4.3, 3, 2.5, 2, 1.5, 1, and 0.6. Okay, looks like I'll need to dig up a cal document for the 966A because the 966 and the 966A are not the same switch pinouts. But to give it a test and see how it's going, let's test some 6L6s. So we have it on the variac and isolation supply. It's 116 volts. We're giving it a moment for the tube to warm up, but we'll do a line adjust. There we go. I've already set the switches correctly, so it's 6.3 volts on the filament. It's JR 53472 with a bias of 23 and a English of 88. We're going to do a GM test. First, we're going to test the tube for shorts. No short, no short, no short. The blink is fine. It's the bulb staying on is the problem. So no shorts on the tube, so we're not going to damage the tester. Tube is lit up. I can see it glowing. And we're going to hit GM. I have it set to English, which is the replace good test. And we have a very healthy 6L6. So let's do a mutual conductance test over here. So we're looking for a mutual conductance of about 5, or well, it looks like 3150 is the drop dead mutual conductance. 5000 is the average. So we will set mutual conductance to 6000. And we will test again. And we are at 5500. So that is a very healthy 6L6. I did grab a second one. And here we go. Give this a chance to warm up. That's a nice and tight socket. That'll be good for testing. Now, this is also a 6L6, so all the settings are the same. But we will also check the line adjust again, just to be safe. We are good. And that is reading right at 5500, so not bad. I request my tube back now. Thank you. Oh man, damn. Thank you. So there we have it. We have a functioning tube tester. Now, do I think this is aligned? Absolutely not. To do an alignment on this, you do need a bogey tube. So the question is, where am I going to get a bogey tube? Also, this doesn't have any alignment resistors, so all I can really do is check it in. This will give me the ability to check tubes for shorts and things like that, and that will be very useful in the lab. But in terms of matching tubes and things like that, I could match them against each other, but I can't match them against somebody else's tester. When you're looking at tube testers, there's two different types of tube testers. There is a lab-grade tube tester, and there's what's called a service-grade tube tester. This particular unit is a service-grade tube tester, which usually means it has a tolerance of about plus minus 5% or 10%. So that's pretty wide when it comes to matching tubes. So I can match tubes to each other with this tester, but at the moment I can't use other people's GM measurements and match their testers to my tester. So what I need to do is I need to very accurately measure the mutual conductance of a vacuum tube here in the lab. Then I can see if this tester agrees. If that's the case, this tester's in pretty good shape and we know it's good to go. If it doesn't agree, well, then I may have to swap around some resistors, not a huge deal. The best way that I'm currently thinking to do that sort of very precise individual validation of a tube so I can get a, quote, cal standard tube for the lab would be to use some of my SMUs. Well, I only have one SMU right now. I'm actually going to need two. And then what I can do is with the SMUs, I can plot the curves. I can use one source measure unit to drive the grid, and I can use the other source measure unit as the plate, and that'll give me some, and then I can plot tube curves and things like that with the SMUs. That'll take a little bit of programming. Be some pretty advanced stuff. Also, the buy-in to that is pretty high. Getting the second SMU that can do 1,000 volts is not on the inexpensive side. But it is something I'm kicking around. Let me know what you guys think in the comments below. And let me know what you guys think of this in the comments below. And we will take a look at some more equipment. I have currently been unpacking a ton of equipment. If there's interest in what's going on behind the scenes, let me know. I'll do a video on it. Might throw that one up on Patreon, I don't know. But, yeah, all in all, pretty happy about this one. This one's actually rated for 110 volts. Just found it. Right here. So I shouldn't even be running this at 117. A little bit of wood screws, same size. These are stainless, since I like doing things once. I try not to do my job twice, even though I do enjoy it. We got stainless fasteners, and these will thread in and fit, so the thread matches, and these are nice wood screws. So when this is closed up, it won't thump in the case anymore, which was this kind of falling against this top plate. So everything I can do to keep the meter from getting scratched up is good. So let me know what your thoughts are in the comments on that 83 tube. If we should replace the 83, if we should replace the solid state rectifier with an 83, redo the measurements. If we should get an SMU in the lab that can do 1,000 volts and script out some testing and test some tubes that way. And then go from there, because once we get a known good tube, we can just verify the readings under similar conditions. But the other thing is, if we go the SMU route, we'll probably have to get an AC power supply for the heaters, because most of the time with tube gear, the heaters are powered off of the AC windings, and they're not DC. Some of the reasons that this thing was acting a little funny, well, not funny yesterday, but the the readings were a little off on the meters is because this is 110 volts on the input, and the lab voltage was running about 126. So we were about 15-ish odd volts, 16-ish odd volts high on the primary. That, of course, is going to carry through the transformer into the rest of the circuit and cause everything to be a little bit elevated due to the fact that this actually doesn't have any real regulation in it at all, to be honest. It has those 2 capacitors, and that's about it. And then the other, and it is DC, so it's rectified, but it's not regulated. And one more hiding behind the meter. Somebody's been in this a lot. These holes are actually pretty blown out. They'll hold, though. I mean, they'll hold the tester in, so we won't have to worry about it, but I want to be gentle with those, so. All right. But yeah, let me know thoughts in the comments, and we will go from there. So that about wraps it up. Thanks for stopping by the lab, taking a look at the Stark 966A, and I will see everybody in the next video, as well as down in the comments. Bye for now.